So the first topic of this new chapter that we're getting into, which deals with applications, what we can use the differential equation for predicting things. First concept deals with what we call critical numbers. These are numbers within a function that are important in determining extrema, which is what we're going to be getting into next. So the definition of a critical number, let a function f be defined at c. What that means is you've got some curve or straight line or whatever, and there's a point c on it. If the slope of that function at c is 0, then c is a critical number of that function. Okay, so again, we're just doing the idea of critical numbers to see how this plays out. Theorem 3.2 says if f has a relative minimum or relative maximum at x equals c, then c is a critical number of that function. We're basically saying the same thing, only slightly different, and introducing the idea of the extrema that I was talking about, which is a minimum or a maximum, or a series of minima and a series of maxima. Okay, so the two things they talk about here are what's going on with the curve. For this one right here, we have this curve right here. We have a minimum here. This ends up higher. We have a maximum right here. And at the maximum right here, we have a slope equal to 0. So the function of x sub 0 is our zero slope, a horizontal slope is a zero slope. That is, by definition, that point right there, or the number of x, is a critical number. Same thing here, kind of an inverted conversion from this right here. These 2 points are the same place within the defined function from a to b. That is your limit. We'll write that as like this. If it was open, we use parentheses. But this is a closed system, and so we call these maxima, or each one is a maximum, and this is the minimum, the lowest point in the curve. This is considered an absolute, these are absolute as well. But more importantly, the slope here is 0. That means the point at which it contacts the curve, that is your critical point. That's your c or your x sub 0. Same thing going on here. Now you've got a curve changing directions. And this point, inflection point here, where it's going down, and then it's going to the right, and now it's going down as it goes to the right. So this point right here, since they're really, I mean, if you take a look at the tangents as you go along, this tangent is the same for this one and for this one. So that's considered a maximum point, a critical point. The maximum of this function from a to b is the absolute right there, the absolute minimum right there. And this is the same curve, only in the inverse direction of it. And this is now the minimum, this is now the maximum, but this slope is found as a tangent for these two right here. And that gives you then your critical point right there. Okay? So what we need to do then is to figure out how to calculate